Hey Dosto, welcome back to our channel. Today we're diving into the fascinating world of time travel. Buckle up as we explore wormholes, paradoxes, and the possibilities of traveling through time. But is time travel just a science fiction fantasy, or could it be a real possibility? Join us as we explore the science behind time travel. Get ready to embark on an incredible journey through the cosmos, where the boundaries of space and time blur. From the dawn of civilization, humans have gazed up at the stars, yearning to explore the vast expanse of the cosmos. But the universe guards its secrets closely, hiding them behind unimaginable distances. Even if we could travel at the speed of light, the cosmic speed limit, it would take years, centuries, even millennia to reach the nearest star systems. But what if we didn't have to travel through the vastness of space at all? What if there were shortcuts, hidden tunnels that connect different points in space and time? These shortcuts, my friends, are what we call wormholes. Imagine a piece of paper folded in half with 2 points marked on opposite ends. The shortest distance between these points isn't across the surface of the paper, but through it. That, in essence, is the concept of a wormhole, a bridge through the fabric of space-time itself. These theoretical tunnels, predicted by Einstein's theory of general relativity, could potentially allow us to travel vast distances in an instant. But how do wormholes work? Picture space-time as a flexible sheet. A massive object like a star creates a dip in this sheet, much like a bowling ball placed on a trampoline. Now, imagine that dip being so deep that it connects to another point on the sheet, perhaps created by another massive object. That connection, that tunnel, is a wormhole. The immense gravity of black holes could potentially warp space-time to such an extent that they create wormholes. The allure of time travel isn't just about exploring the cosmos. It's about unraveling the mysteries of our own past and glimpsing into the possibilities of the future. The concept of moving through time has fascinated humanity for centuries, sparking countless stories and theories. But time, as we're beginning to understand, is a tangled web, and the very act of traveling through it could have unforeseen and perhaps disastrous consequences. The ripple effects of even the smallest actions could be monumental. One of the most perplexing puzzles in the realm of time travel is the grandfather paradox. It forces us to confront the mind-boggling implications of altering the past, and the potential for creating paradoxes that could unravel the very fabric of our existence. The paradox challenges our understanding of reality and causality. Imagine, if you will, that you've built a time machine. You decide to embark on a journey to the past, perhaps to witness a historical event firsthand, or even to right a wrong that has haunted you for years. The motivations for such a journey can be deeply personal and emotionally charged. But what if, in your quest to change the past, you inadvertently prevent your own existence? Let's say you travel back in time and, through a series of events, cause your grandfather to never meet your grandmother. Without that fateful encounter, your father would never have been born, and neither would you. But if you were never born, how could you have traveled back in time to change the past in the first place? This paradox creates a loop of impossibility. This is the crux of the grandfather paradox, a logical contradiction that arises when we consider the possibility of changing the past in a way that alters our present. It throws into question the very nature of cause and effect, of free will versus determinism. Are our actions predestined, or do we have the power to change our fate? Some physicists believe that the grandfather paradox highlights the impossibility of changing the past. They argue that the past is fixed, unchangeable, like a movie that's already been written and screened. Any attempt to alter it would be like trying to edit a film as it's being projected, futile and ultimately meaningless. The past, in this view, is a closed chapter, immutable and eternal. Chapter 3. Real-life evidence of time travel. The human mind, with its boundless curiosity, is constantly searching for patterns, for connections, for evidence of the extraordinary hidden within the mundane. This quest often leads us to question the very fabric of reality and the nature of time itself. And so, throughout history, there have been countless tales, whispers, and rumors of time travel, of individuals claiming to have crossed the barriers of time, or of objects appearing out of place and out of time. These stories captivate our imagination and challenge our understanding of history. One of the most intriguing pieces of alleged time travel evidence comes in the form of mysterious photographs. These images often spark debates and discussions among enthusiasts and skeptics alike. These images, often grainy and faded, seem to depict people or objects that appear strangely out of place for their era. They raise questions about the authenticity of the photographs and the possibility of time travel. Take, for example, the enigmatic time-traveling hipster photograph from 1941. This particular image has become a focal point for discussions about time travel. This image, taken during the reopening of the South Fork Bridge in British Columbia, captures a crowd of people dressed in typical 1940s attire. The scene is a snapshot of history, frozen in time. However, one man stands out, a young man sporting sunglasses, a printed t-shirt, and a hairstyle that seems decades ahead of his time. His appearance is strikingly modern, making him an anomaly in the photograph. Skeptics argue that the man's clothing and appearance, while unusual for the time period, could simply be attributed to fashion trends that were ahead of the curve in certain circles. They suggest that such anomalies can be explained by the diversity of fashion and personal expression. But believers in time travel point to this photo as evidence that perhaps someone from our future or another timeline has visited our past. They see it as a tantalizing glimpse into the possibilities of time travel. Then, there are the ancient texts that describe events or technologies that seem far too advanced for their time. These texts often contain detailed descriptions that defy the technological capabilities of the era. The ancient Indian epic, the Mahabharata, for example, describes flying machines called vimanas that possessed incredible speed and weaponry. These descriptions have led some to speculate about ancient advanced technologies or even time travel. Some interpret these descriptions as evidence of advanced ancient civilizations or even extraterrestrial contact. They argue that such advanced knowledge could only come from a source beyond the known capabilities of the time. While these interpretations are fascinating, it's important to approach such claims with a healthy dose of skepticism. Critical thinking and rigorous analysis are essential when examining these extraordinary claims. Ancient texts are often filled with symbolism, allegory, and cultural nuances that can be easily misinterpreted. Understanding the context and intent behind these writings is crucial. Attributing them to time travel or alien intervention often requires a significant leap of faith and a disregard for more plausible explanations. It's a reminder that while the idea of time travel is captivating, we must remain grounded in our quest for truth. Chapter 4. Will humans ever time travel? The dream of time travel, of venturing into the past or leaping into the future, has captivated humanity for centuries. From ancient myths to modern science fiction, the allure of transcending the boundaries of time has always sparked our imagination. But can this dream, so deeply ingrained in our science fiction and fantasies, ever become a reality? Is it possible that one day, we might actually build a machine that can take us to different points in time? The answer, like the very nature of time itself, is complex and shrouded in uncertainty. Time, as we understand it, is a dimension interwoven with the fabric of space, creating what we call space-time. As of now, we don't possess the technology to build a time machine like the ones we see in movies. The concept of a DeLorean speeding through time remains firmly in the realm of fiction. The laws of physics, as we currently understand them, present formidable challenges to time travel, particularly traveling to the past. The paradoxes and complexities involved are immense. However, amidst the vast unknowns of the cosmos, there are glimmers of hope, theoretical possibilities that keep the dream of time travel alive. The universe is full of mysteries waiting to be unraveled. Scientists, ever the explorers of the unknown, are delving into the mysteries of quantum physics, black holes, and the very fabric of space-time, searching for clues that might one day unlock the secrets of time travel. Their research is pushing the boundaries of what we know. One avenue of exploration lies in the realm of time dilation, a phenomenon predicted by Einstein's theory of special relativity. This theory has been tested and confirmed in various experiments. Time, it turns out, is not absolute but relative to the observer's frame of reference. This means that time can flow at different rates depending on various factors. Time passes slower in stronger gravitational fields or at speeds approaching the speed of light. This effect, though subtle, has profound implications for our understanding of time. Imagine two synchronized clocks, one remaining on Earth and the other sent on a high-speed journey through space. This thought experiment helps us grasp the concept of time dilation. Upon its return, the traveling clock would show a slightly slower time compared to the Earth-bound clock. This difference, though minute, is a real and measurable effect. The difference in time, though minute at everyday speeds, becomes more significant as we approach the speed of light. This opens up fascinating possibilities for future space travel. This means that astronauts aboard the International Space Station, for example, experience time slightly slower than we do on Earth. This phenomenon, known as time dilation, is a small but real form of time travel. While the difference is minuscule, it demonstrates that time travel to the future, in a sense, is already a reality, albeit on a very small scale. This gives us a glimpse into the potential of time travel. To achieve more significant time dilation, we would need to travel at speeds approaching the speed of light, or venture close to incredibly massive objects like black holes. These scenarios, while currently beyond our reach, are not entirely out of the realm of possibility. However, reaching such speeds with our current technology is beyond our capabilities, and approaching a black hole remains a perilous endeavor. The challenges are immense, but so are the potential rewards. Another avenue of research focuses on harnessing the power of wormholes. These theoretical passages through space-time could, in theory, allow for instantaneous travel between distant points in time and space. Thanks for watching, Dosto. If you enjoyed this video, make sure to like, share, and subscribe for more fascinating content. Until next time, keep exploring the mysteries of the universe. From the mind-bending possibilities of wormholes to the perplexing paradoxes of time travel, we've only just scratched the surface of this enigmatic subject. But remember, every great discovery, every scientific breakthrough began with a question, a spark of curiosity. So keep asking those questions, keep exploring the world around you, and never stop searching for answers. The universe is full of mysteries waiting to be unraveled, and who knows what incredible discoveries await us in the future. Imagine waking up in a strange bed. The sheets feel different, the air smells unfamiliar, and the room is filled with gadgets and technology you've never seen before. You sit up, trying to make sense of your surroundings, but nothing seems to add up. The walls are sleek and metallic, and there's a soft hum of machinery in the background. You feel a mix of confusion and curiosity as you try to piece together how you ended up here. You look out the window and see towering skyscrapers, their glass facades reflecting the morning sun. The cityscape is unlike anything you've ever seen, with buildings that stretch impossibly high into the sky. The architecture is both alien and awe-inspiring, a testament to the advancements of this new world. You can't help but wonder what kind of society built these marvels and what life is like here. Flying vehicles zip across the sky, moving with a grace and speed that defy the laws of physics as you know them. These aren't just cars, they're sleek, aerodynamic machines that hover and glide effortlessly. The sky is a bustling highway of these futuristic vehicles, each one a marvel of engineering. You watch in amazement, trying to comprehend the technology that makes such wonders possible. Disoriented, you check your phone. The date reads 21/25. Your heart races as you realize you've somehow been transported over a century into the future. The phone itself is a piece of advanced technology, with a holographic display and features that seem straight out of a science fiction movie. You scroll through the interface, trying to find any clue that might explain your situation. Somehow, you've been transported a century into the future. The realization hits you like a tidal wave, bringing with it a flood of questions and emotions. How did this happen? Is there a way to return? What has become of the world you once knew? You feel a mix of excitement and fear as you contemplate the possibilities and challenges that lie ahead. Now picture this. You open your eyes to find yourself surrounded by towering trees and unfamiliar sounds. The air is thick with the scent of earth and foliage, and the ground beneath you is soft and damp. You hear the distant calls of strange creatures and the rustling of leaves in the breeze. The forest is dense and ancient, a living testament to a time long before human civilization. You feel a chill in the air, and notice people dressed in animal skins. They move with a primal grace, their eyes sharp and alert. These are the inhabitants of this prehistoric world, living in harmony with nature and relying on their instincts for survival. You watch them with a mix of fascination and trepidation, wondering how you will navigate this ancient landscape. You've traveled back in time, to the prehistoric era. The realization is both thrilling and terrifying. You are now a visitor in a world that existed long before the dawn of modern civilization. The challenges you face here are unlike anything you've ever encountered, and you must rely on your wits and adaptability to survive. The prehistoric landscape is a harsh and unforgiving place, but it is also filled with wonder and discovery. These scenarios, while fantastical, capture the essence of time travel, a concept that has fascinated humanity for centuries. From ancient myths to modern science fiction, the idea of moving through time has sparked our imagination and inspired countless stories. Time travel represents our deepest desires to explore the unknown, to correct past mistakes, and to glimpse the future. It challenges our understanding of reality and pushes the boundaries of what we believe is possible. But is it merely a product of our imagination, confined to the realms of science fiction, or could it be a real possibility? Scientists and researchers have long pondered the mysteries of time, exploring theories of relativity, quantum mechanics, and the nature of the universe. While we have yet to unlock the secrets of time travel, the pursuit of this knowledge continues to drive innovation and discovery. Perhaps one day, the dream of traveling through time will become a reality, opening new frontiers for humanity to explore. To comprehend time travel, we must first grasp the nature of time itself. Time, as we experience it, is a constant, ever-present force that governs our lives. From the moment we wake up to the time we go to bed, we are bound by the ticking of the clock. But what if time is more than just a sequence of events? What if it is a dimension that we can explore and manipulate? We perceive time as a linear progression, a steady march from the past, through the present, to the future. This perception is deeply ingrained in our consciousness, shaping our understanding of reality. However, this linear view of time is just one way to look at it. In reality, time is much more complex and multifaceted. It is a dynamic entity that can be stretched, compressed, and even looped. Yet physicists view time as the fourth dimension, intricately interwoven with the three dimensions of space to form a unified fabric, space-time. This concept, introduced by Albert Einstein in his theory of relativity, revolutionized our understanding of the universe. According to this theory, massive objects like planets and stars can bend the fabric of space-time, creating what we perceive as gravity. This bending of space-time also affects the flow of time, causing it to slow down or speed up depending on the strength of the gravitational field. Just as we can move left or right, forward or backward, up or down in space, could we also navigate through time? This idea has fascinated scientists and philosophers for centuries. If time is indeed a dimension, then theoretically, it should be possible to move through it, just as we move through space. This would open up a whole new realm of possibilities, allowing us to visit different eras and witness historical events firsthand. Could we journey to the distant past or the far future just as easily as we travel to different locations in space? The concept of time travel has been a popular theme in science fiction, but recent advancements in physics suggest that it might not be as far-fetched as it seems. While we are still far from building a functional time machine, the study of space-time and the nature of time itself continues to push the boundaries of our understanding, bringing us closer to unlocking the secrets of the fourth dimension. In the early 20th century, Albert Einstein revolutionized our understanding of space and time with his theory of relativity. Einstein proposed that time is not absolute but is relative to the observer's frame of reference. This means that time can pass at different rates for observers who are moving relative to each other. This concept, as mind-boggling as it may seem, has been experimentally verified countless times. Atomic clocks, accurate to within a fraction of a second over millions of years, have shown that time slows down at high speeds and in strong gravitational fields. One of the most intriguing consequences of Einstein's theory is time dilation. Imagine a spaceship traveling at a significant fraction of the speed of light. According to relativity, time would pass slower for the astronauts on board the spaceship compared to people on Earth. For instance, if the spaceship traveled at 99% the speed of light for what the astronauts perceived as 1 year, 10 years would have passed on Earth. This means the astronauts would have effectively traveled 10 years into the future. Section 5. The Twin Paradox, a Journey Through Time. The implications of time dilation are vividly illustrated in the famous twin paradox. Consider two identical twins. One twin remains on Earth, while the other embarks on a high-speed space voyage. Upon the traveling twin's return, they would be younger than the twin who stayed on Earth. This is because time would have passed slower for the traveling twin due to their high speed, effectively allowing them to travel into the future. Section 6. Wormholes, shortcuts through space and time. While time dilation offers a tantalizing glimpse into the possibility of traveling to the future, What about journeying to the past? Some physicists believe that wormholes, hypothetical tunnels connecting different points in space-time, could potentially allow for backward time travel. Imagine space-time as a sheet of paper. Folding the paper in half brings two distant points close together. A wormhole would act like a shortcut through this folded space-time, potentially connecting different points in time as well as space. Section 7. Time travel paradoxes, a tangled web. The prospect of time travel, however, raises a plethora of paradoxes that challenge our understanding of causality and the nature of reality. One of the most famous is the grandfather paradox. Imagine traveling back in time and accidentally killing your grandfather before your parent was born. This would mean you would never have been born. So how could you have traveled back in time to kill your grandfather in the first place? Section 8. The enigmatic nature of time. Such paradoxes highlight the complexities and uncertainties surrounding time travel. While Einstein's theory of relativity allows for the possibility of time dilation and even time travel to the future, the feasibility of backward time travel remains highly speculative. The laws of physics, as we currently understand them, do not explicitly forbid time travel, but the scientific community is divided on whether it is truly achievable. Section 9. Conclusion. Time travel, a dream deferred. The dream of time travel, once relegated to the realm of science fiction, has captivated human imagination for centuries. From H.G. Wells' The Time Machine to modern-day movies and TV shows, the concept of moving through time has been a source of endless fascination and speculation. The idea that we could visit the past to witness historical events or leap into the future to see what lies ahead is both thrilling and daunting. While the possibility of traveling through time remains an open question, the pursuit of this elusive dream continues to inspire scientific inquiry and push the boundaries of our understanding of the universe. Researchers in fields ranging from quantum physics to cosmology are exploring the fundamental nature of time itself. They are investigating whether the fabric of space-time can be manipulated to allow for temporal journeys. Theoretical models such as wormholes and the concept of a multiverse offer tantalizing glimpses into how time travel might be achieved. Perhaps one day we will unlock the secrets of time and embark on extraordinary journeys through the annals of history or to the distant shores of the future. Imagine the possibilities, witnessing the construction of the pyramids, meeting legendary figures like Leonardo da Vinci, or exploring the technological marvels of the 22nd century. The potential for discovery and adventure is limitless. Until then, time travel remains a tantalizing enigma, a testament to the boundless possibilities that lie at the frontiers of human knowledge. It challenges us to think beyond the constraints of our current understanding and to dream of what might be possible. As we continue to explore the mysteries of time, we are reminded of the enduring power of human curiosity and imagination. Whether or not we ever achieve the dream of time travel, the journey of discovery itself is a remarkable adventure.